Welcome to EDU Aero Classroom. In this tutorial, we will discuss integral power of iota and imaginary quantities. Firstly, we will discuss integral power of iota. Integral power of iota means the power of I. I is a symbol which is used to denote iota. And the concept of iota has been introduced to find the square root of -1, that is a solution of x square plus 1 is equal to 0 equation with the property that is I square is equal to -1. We also call this symbol as the imaginary unit. Now let us discuss its integral power. That is I is equal to under root of -1. I square is equal to minus, that is squaring both sides. That is, if we do the squaring both sides, we get square of this, that is under root will be cancelled out by square, so we get -1. Similarly, I cube will be equal to I square into I. We can write I cube as I square into I. So I square is equal to -1. I is equal to under root of -1, or we can say that minus of I. Similarly, I4 is equal to I square whole square, is which will equal to -1 whole square, because I square is equal to -1, minus 1 whole square is equal to 1. So we will use this various integral power of iota in solving our question. So these are the 4 basic integral power of iota on which we can reduce the higher power of iota to this power and we can solve our question. Moreover, in order to compute I raised to n for n greater than 4, we divide n by 4 and obtain the remainder. And denote the remainder by r. Let m be the quotient when n is divided by r. 4. Then n will be equal to 4m plus r by the property of divisor and quotient, where r lies between 0 and 4. Taking I on by both sides and raised to this, we get I raised to n will be equal to I raised to 4 into I raised to m plus or into I raised to r, which will be equal to, this I write I raised to 4 whole raised to m, because 4m is there, into I raised to r, which will be equal to I raised to r. So in order to compute the I raised to n will be equal to I raised to r. So this is the algorithm or step which we have to follow to compute I raised to n. First divide n by r, then remainder I raised to remainder will be the I raised to equal to I raised to n. This is the result which we compute. That is I raised to n will be equal to I raised to r, where r is the remainder when divided by r. If we have to compute I raised to minus n for n greater than 4, then this will be equal to 1 upon I raised to n, which will be equal to 1 upon I raised to r, where r is the remainder when divided by 4. One more thing which we have to remember, that I raised to 0 is equal to 1. So we conclude that in order to find out I raised to n, I raised to n will be equal to I raised to r, where r is the remainder when divided by 4, and I raised to minus n will be equal to 1 upon I raised to r, where r is the remainder when divided by r. Now let us see the example based on this. In this question, we have to solve this equation. Now let us solve this equation. Firstly, we have to compute I raised to 19. In order to compute I raised to 19, we have to divide 19 by 4 in order to find out the remainder. So when we divide 19 by 4, we get 4, 4 just 16 is 3. We get 3 as remainder. So as we know that I raised to n is equal to I raised to r, and I raised to minus n is equal to 1 upon I raised to r. So we use these formulas while solving this question. So we compute I raised to 19 as I raised to 3, because 3 is the remainder when 19 is divided by 4. Similarly, 1 by I raised to 25 will be equal to 1 by I raised to 25 and whole square, which will be equal to I raised to 3 is equal to minus I and 1 upon I raised to 25. Similarly, here we will divide 25 by 4, we get 5 is 24, 1 as the remainder. So here it will be 1 upon I raised to 1, that is 1 upon I whole square. In order to compute 1 upon I, we multiply numerator and denominator by I cube in order to make in the denominator I raised to 4, because we know that I raised to 4 is 1. This will be equal to I raised to 4 is 1 and I cube is I. So we get minus I plus I cube raised to 2, because I raised to 4 is equal to 1. Here why we divide I raised to 3 and I raised to 3 in both numerator and denominator, because in order to make denominator I raised to 4, because we know that I raised to 4 is equal to 1. This will be equal to minus I raised to cube is minus I. This will be minus 2I whole square, which is equal to 4I square, which is equal to minus 4, because I square is equal to minus 1. So the value of this equation is equal to minus 4 is the required answer. In this way, we can compute the various values of I raised to n and I raised to minus n and solve this type of question. Now we will discuss imaginary quantities. The square root of a negative real number is called imaginary quantity or an imaginary number. For example, under root of minus 3, under root of minus 3, all these are imaginary number or imaginary quantities. There is one result based on imaginary quantities, which is under root of minus a into under root of minus b is equal to minus of under root of ab, because we know that under root of minus 1 is I, so this will be equal to I into root a, and this similarly this will be equal to I into root b, and this will become I square into root ab. I square is equal to minus 1 into root ab, which is equal to minus root 8. So under root of minus a into under root of minus b is equal to minus of under root of ab. This is our result. Now let us see one question based on this. In this question, we have to compute this equation. Now let us compute this. Under root of minus 4 will be equal to I root 2, because under root of minus 1 is equal to I and under root of 4 is equal to 6. By using these two, we get this term. Similarly, over here, under root of minus 9 will be 3I and under root of 4 is 2. So this is bracket, not under root. We have already solved. So we get 3i over 2. So this will be equal to I square into 3 root 2 divided by 2. Sorry, I did a mistake. We will solve this question from starting again. Here, under root of minus 4 will be equal to I into 2, that is 2i, because under root of minus 1 is equal to I and under root of 4 is equal to 2. This will be equal to 2i. And similarly here, under root of minus 9 will be 3i and under root of 4 is 2. So we get this term, 2 will be cancelled out by 2. We get 3i square, which is equal to minus 3, because I square is equal to minus 1. So the value of this term is equal to minus 3, which is our answer. So in this way we can compute the imaginary quantity.